Alright, so everybody ready to get started? Yep. So what you'll need to do is to have your books open to 235, please. Alright? 235. So what we'll do is we'll break this into a sequence of topics, if you like, for the organic chemistry section. And what we're going to do today really is we're going to look at a little bit of revision. It's going to be nomenclature, which basically is naming organic compounds, just as a quick revision, because we did that in stage 1. And then we're going to look at the second section on physical properties of organic compounds. All right, so that's the plan for today, to look at those two things. All right, now, in terms of structures and organic compounds, when we look at organic structures, obviously they are based on carbon. And so we use the word hydrocarbon extensively to explain most organic compounds, given that they've also got nitrogen in them, and they've got oxygen, and they've got halogens in them. There's a whole variety of organic compounds that we'll look at. Essentially though, we look at something called aliphatic compounds. Aliphatic means they have got no benzene ring in their structure. So the term aliphatic is a general term. There is also a whole group of organic compounds, and they are called aromatic organic compounds, and they have got benzene in their structure. Now, if you remember the structure for benzene, there's a few ways we can draw benzene. So we have got a 6-membered ring, and we can look at benzene in that format, or you'll see benzene drawn also in this format, because the single bonds and double bonds aren't really single bonds and double bonds. It's a little bit unique. So benzene has got 6 overlapping orbitals, they're the p orbitals, so they actually really share. It's halfway between a single and a double bond in the structure for benzene, so it's a flat structure. So if I see a massive organic compound, and somewhere in that compound, it doesn't matter what's sitting off that chain, okay, might have an OH here, as soon as I see somewhere in the structure a benzene ring, then it's categorised as an aromatic hydrocarbon, or an aromatic organic compound. The word aroma, aromatic, so they're typically also high in odour. So anything that's got a benzene ring is aromatic. Underneath the aliphatic, there are a whole series of terms that we have to become familiar with. We can have basically what we would call a straight chain. So the straight chain compound is typically things like, if we look at just propane, is a straight chain aliphatic compound. We can also have cyclic aliphatic compounds, not to be confused with benzene, which is obviously cyclic. And so we can have, within this structure, we can have 5-membered rings, and we can have 6-membered rings, okay, that form cyclic structures within the aliphatic category. So obviously that has got a carbon and 2 hydrogens here, because this is our stick structure that we'll talk about in a minute, and 2 hydrogens off this one here. So that would be a 5-membered ring, and hopefully you can probably work out that would be called cyclopentane. This one here, it's got 6 carbon, would be cyclohexane. So things like that hopefully are obvious. So cyclohexane, and the word cyclopentane comes in. Not that it's huge, but it may come up in naming of some compounds. Within the aliphatic, another branch from the aliphatic section, we also would have talked about 3 groups of compounds. Do you remember what they were called at year 11? We had a general term at year 11 that comes into this as well. Starts with the H. H. Homologous series. And from last year, homologous series is like a family of organic compounds. So they all can be generated from a single formula, okay? And they all differ typically by one carbon. So if I were to look at a formula, say, for the alkanes from last year, when we look at the alkanes, if you remember, they've only got single bonds in their structure. So if I were to come up with a general formula for an alkane, it's easier to draw the alkanes and then work backwards from the structure, knowing they've all got single bonds. So the formula for the alkane is CnH2n plus 2, where N is the what? Number of carbons. Okay? So we start at carbon number 1 for the alkanes, and then the assumption is, without me going through it again, you should be able to remember things like methane, ethane, propane, up to 10. Alright, we end at the decade. So the number of carbons is something that you need to bring back, alright, into your head, alright, when we look at nomenclature again, because we have to identify how many carbons are in a chain, but we don't go any more than 10. Alkenes, we also spoke about last year, and they are characterised by a double bond, and the formula is CnH2n. Right, and again, what's the first member of the alkene series? Methane. Who agrees with that? That means one carbon. So I can have one carbon. Let's have a look at it. So one carbon, and that means it would have to look something like that. Does that work? No. So we can't have, okay, a single carbon, hydrocarbon, this is, all right, in the alkene structures. That ain't going to work. So the first member in the alkene series is going to be ethene or ethene, okay, or ethylene. We talk about trivial and systematic names. So the systematic name is ethene. All right, the trivial name will be ethylene, or as a common name. All right, so the first member is not methane. It does not exist. The first member in the alkene homologous series is obviously going to be ethene. Then we work out, or we go to the alkynes, and in the alkynes, one triple bond somewhere in the structure. And Jack, what are they called? Oh, sorry, of course they're called alkynes. What's the formula for them? CnH2n. No, we can work it out. So this is how you'd actually do it. All right, so you draw maybe the first member of the alkynes, and then I probably might draw another one. Then I'll put in all the hydrogens, one there, and there's one there. So if you can't work out, or if you can't remember the formula, easy, work it out. All right. So here, N would be 3, C3, and it obviously is 1, 2, 3, 4, H, 1, 2, 3, 4. Okay, and hopefully you can work it out. That would be CnH2n take 2. 2 3s are 6. Take 2 because we get back to 4. I check it. Here C is 2. That would be C2H2. That works. All right. So you should be able to work out the generic formula, or the formula for all of the alkanes, and alkynes. And you can also do the same thing for alcohols and alkyl halides and aldehydes. All we do is we split off the functional group. So if I said, for argument's sake, because we're looking at alcohols as a homologous series, there will be 10 alcohols going from methanol up to decanol. The general formula will be CnH2n plus 1, and then we drag out the functional group, which is the alcohol. Of course, all I've done is I've taken a straight hydrocarbon chain, that originally had a hydrogen there, and I've taken off that, and I've put on an OH. So here is the CnH2n plus 1, and we just put a functional group on the end of it. And that'll work with all the functional groups. So it could be a carboxylic acid functional group. Okay, provided the, what's the assumption that I've made there already? What's the assumption I've made there? Is that one? What have I just sort of automatically assumed with the carbon chain if I'm using that formula? Only single bonds. Okay, so that may not always be the case, but if it's a straight chain, homologous series for the carboxylic acids, simple chain, okay, then that formula would apply. All right, so that's just a little bit of quick revision. Within that stuff that we did last year, we also used or talked about some categories, okay, that are on the board. We use another term. So within this section here, and this section here, we even group these compounds further. Does anybody remember what they were called? Saturated, all right? So then we use the idea of saturated hydrocarbons, and then we use the idea of unsaturated. So we could have an unsaturated cyclic aliphatic compound, which means it's a cyclic compound. It's got some sort of a circle in it somewhere. It is got only carbons and hydrogens. It's got no benzene, and it's got a double bond or triple bond somewhere in the structure. So we can combine all these terms together. So this is just a general idea in terms of structural formula structures. So all organic compounds will fit into one of these categories. All right, any questions so far? Very cool with that. All right, now, so that's all just simply a revision, okay? What I'm going to do is I'm going to wipe the board and we'll get started with some general naming rules for organic compounds. While I'm on that, okay, and I've just made the assumption, all right, that you know about formulas as well. I need to actually also highlight formulas. So there are obviously 3 formulas that we have to know, and I'll look at one example, all right? There is the structural formula, okay, there is the stick formula, and then there's the condensed structural formula, and they're all a little bit different. So if I were to look at an example of something like that, we'll look at, let's look at, say, propane. So we'll use propane as an example. Simple hydrocarbon. If I said, what's the molecular formula? You would say C3H C3 8 2 3 is 6 plus 2, good, 8. All right, that would be the molecular formula for propane. If I said I want the structural formula, you would write it like this: 1, 2, 3, and of course we would need to show all of the hydrogens in the structure. By the way, in the exam, are you going to show all the hydrogens in the structure? Yes. Yes, you are, all right? Because if you don't, it'll be marked incorrect. If you're doing nomenclature and naming compounds in the book as we go through practice questions, no. You just stick to the skeleton chain, to the carbon chain, just the skeleton, all right? You don't need to show all the hydrogens. But in a test or an exam, you do need to show in all the hydrogens. While we're on that, if you have a structural formula and you do it like that, that's deemed wrong. So you've got to align the bond, obviously, with the atom, all right? Similarly, if you do something like this, do that, it's also wrong, because the hydrogen's sitting in no man's land, all right? So you've got to make sure that, I know that you'll be rushed when you do this, but you have to make sure that when you're doing structural formula, because these are like, thank you very much for coming, I like structural formula because it's simple type questions. So you need to make sure that you don't lose marks just because you happen to be in a rush and you've moved the carbon or the hydrogen so it doesn't look right. So don't throw marks away like that. Alright, now, back to that. So we've got the molecular formula, the structural formula. Okay, that is the stick structure. Remember, wherever there's a termination, it means a carbon. Wherever there's a bend, it means it's a carbon. So there's a carbon here, there's one here, there's one here, and then you're going to have to go back and fill in all the hydrogens, okay, for the valency for carbon. Should be straightforward. Condensed structural form will be something like this. It will be CH3, CH2, CH3. Every termination, so if I just gave you this, at the end there's a carbon there and there's a carbon there. Okay, now you've got to fill in all the hydrogens. So this is the skeleton, the absolute backbone of the structure. How? You know the valency for carbon is 4. You know these are single bonds. So you should work out there's going to be 3 hydrogens there. There's going to be 2 hydrogens here, and there's going to be 3 here. So actually, in an exam or a test, I would be doing this. I would be actually putting on top of the structure all of the actual atoms. So I'm sort of not losing any marks because the typical thing is here's a structure. What's the molecular formula? It's a no-brainer. All right, C2H100, isn't it? What is it? C2H6. All right? Should come to you just like that. All right? So you say, thanks very much for that question because I like those types of questions. So what we have is as follows then. So we've got, again, the molecular formula, structural formula, the advanced, that's showing everything in space. Stick structure, and the condensed structural formula, and you can write the condensed structural formula like this. You'll see it in a variety of ways, CH2 and then CH3. Or either of these is fine. You'll see in the textbook they accept either of those as being fine for the structure. Alright, so all we're doing is grouping all the hydrogens and bundling them together. Alright, so I forgot to mention that. Everybody happy with that? Alright, so that's just condensed structural formula. Naming organic compounds. Let me get rid of... Have you already got all this now? What video? Alright, now, let's have a look. So when we name organic compounds, and I think what I'll do is, I'll just go back and we'll look at a very simple example. Alright, so I'm going to draw a structure first. Something like that. That'll do. And we'll stick to a hydrocarbon structure first, and it's only a skeleton structure. Okay? So when we're naming organic compounds, can anybody recall the rules that we used last year?
It's the longest chain.
Longest chain. Okay? So number 1 is you need to pick out in any structure the longest chain. Alright? And where do we start numbering from? Because I can number 1, 2, 3, 4, 5, 6. Or I can go 1, 2, 3, 4, 5, 6.
Decide the functional groups
or the what are these things called?
branches.
Branches or substitutions, yeah. Alright? So we're looking at, we number from the side with, and all obvious, should be obvious, with a functional group first, that's more important, or what we will call branches, or I just use the word substitutions. Alright, so up here, I'm then going to start numbering from the right hand side. So this one here will be 1, 2, 3, 4, 5, 6. So I just know it's going to be hex somewhere in the name straight away. Alright, now last year again we started doing this. I've got, this is a branch and this is a branch. These are called also alkyl groups, by the way. They're called alkyl branches because they're based on an alkane. All of them will be. So, what are the branches, by the way? What's this one called? A single carbon. It's called a methyl or a methyl group. So here is my methyl branch. We can have, in a structure, we can have actually this sort of a branch. That's not a complete compound, it's just a snapshot of, you know, of one part of the compound, obviously. If that was a branch somewhere, what would that be called? It'd be called an ethyl branch, or an ethyl. Okay. Occasionally we get this one, but not very much. If I have a branch like that, and I'm naming it as a single entity, it's called a propyl branch. And very rarely we end up with this one. It's not actually in the book, but sometimes we end up with this one. What's that branch called? It's only got 3. So if that was a snapshot of somewhere in a big long carbon chain, and this was not in the carbon chain, because you've got to be careful when you're numbering the chain, longest carbon chain. So this is an isopropyl branch, okay? But I don't think we'll see that in many examples. I think there's only one in the questions that I'm going to give you, all right? So these branches, you've got to remember, 1 carbon is a methyl, 2 is an ethyl, 3 is a propyl, and maybe you might get this one here, an isopropyl. If there was a 4 branch, do you think it's going to, what would you think that would be called? It could be a butyl or a butyl branch. Read about that? Okay. Now, back to our naming then. So we've got the side with the most substitution. So if I were to sort of draw a line in the middle of that structure, it's pretty heavily weighted to the right-hand side. When I say weighted, it's got methyls in that group, so hopefully you can work out that I'm going to start from that side. So I've now identified the numbering, I know the length of the chain, and I've numbered it from the right side. What do I need to do next? Smarty, what do I have to do next?
Will we substitute the groups in?
The groups, okay. So we've actually have to look at the groups. We have to look at the
function groups themselves.
Yep, the carbon number, and I'll put up here to what is on that carbon.
Yeah.
And then. So what do we got? We've got this one and this one. We've got this and this. So that will be 2, 3.
Yeah.
All right. Between numbers, we put a dash or a comma? Comma. 2, 3, dash. Di. Methyl, dash. Okay. Hex.
You have to dash between words.
You don't have to, but I do it between the numbers and the words here.
Yeah.
You can drop that one if you want to, all right? But it just helps me to pick out every section of the structure. So 2, 3, dimethyl, hexane. I could put a dash ane, but we'll leave it simple, hexane. So the other thing we didn't mention in our naming was this. So if we've got multiple substitutions of the same sort of group, it becomes a di or a tri, or sometimes we'll see tetra. All right? If we've got 4 substitutions of the same sort of branch, all right, in the compound. All right, so that's naming organic compounds, and you're going to have heaps and heaps of examples shortly of naming organic compounds. The ones I think we're going to look at, we're going to keep it simple in the first instance, and it looks like we're focusing on, no, we're not going to. We've got a sort of a bit of a mix of compounds, so I'll just run you through those very quickly. So if the branches are simply carbons, it's reasonably straightforward. But we've now got to actually understand about naming our functional groups. So in our functional groups, the ones that we're going to cover for this topic, I'm going to go down and we're going to list them fairly quickly. So the functional groups that we're going to do in this sort of order are going to be the alcohol functional group, and I'm just going to put down there just the OH. That'll be our first functional group that we're going to look at. Then we're going to look at the aldehydes, and it goes RCOH, or I should say it goes RCHO. That's how we draw that one. The hydrogen is bonded to the carbon, not the oxygen. Okay? Then we're going to do carboxylic acids. And we'll do one structure for each one of these, and we'll show you how we name these. All right? So carboxylic acids are RCOOH, or you can see it sometimes written as RCO2H, doesn't matter, it's the same thing. Then we're going to do from there, maybe we're going to do amines, and amines are RNH2. And then we're going to do amides, they are C double bond O NH2. And then we're going to do esters, and one of our practicals late this year, when I say late, not too late, next term will be esters, and that is based on this structure here. It's RCOOR if you want to combine together. OR dash.
What is the R dash?
Okay, good. What does the R dash mean? R is a general carbon chain, and R dash just means a different number of carbons. That's all it means. Okay, but if I had R, it wouldn't matter. It's just a carbon chain. I can have the same number of carbons. If I had R and R, that would be like one carbon, and that would be one carbon. It's just a general formula to represent structural stuff. All right, on that scale. All right. So we've got alcohols, aldehydes, carboxylic acids, amines, amides, esters. Oh, one thing I forgot. We don't do anything on them, but we just have to be aware of the structure. Is a ketone. So a ketone, okay, it looks like that. It's got a long carbon chain, C double bond O. This structure is actually called a carbonyl. All right, it's not a functional group, but the C double bond O, general term, is a carbonyl. So this is when you've got a C double bond O partway along the chain, very similar to an aldehyde, but I'll swap the hydrogen with a carbon chain. All right. While we're on the idea of functional groups, one of the things that we like to do in questions for organic is we like to create molecules, make molecules, look at structures in questions, and we like to have lots of functional groups in them, molecules you've never seen before. Okay? But it doesn't matter what is in the functional group, what we will learn is how do alcohols react and how do we make alcohols, and how do aldehydes react, how do we make aldehydes. So you learn this set of rules, or a set of guides, if you like, that you're going to follow, and then you apply that to every structure you come across, okay, in some sort of order, of course. So it's meant to be relatively straightforward, all right, if you break the structure down into all the separate functional groups. All right, naming, let's look at the alcohols. We don't have to do all of these because we don't need to name those. We don't need to name those. We just name amines. Yeah, big deal. Only one we don't have to name. Okay, amides, and in the amines we only have to name primary amines. But you can check that for me in the course content. All right, now, so alcohols. If I have got this up here, 1, 2, 3, and I'll put an OH there, and I'll do the condensed structural formula. That would be a H. If I had to name this alcohol, nothing changes. The rules say longest carbon chain. Does it make any difference where we number it from? No. All right, so it goes 1, 2, 3 is the longest carbon chain. Now, on carbon number 2, it is an alcohol functional group. Two ways we can do this one now. Prop. Okay. Now, is it a general flat, is it an alkane, or is it an alkene, or is it an alkyne? Alkane. So it's propane. Propane number 2. Ol. So propane 2-ol. No confusion, all right, with that structure. Alright? Yeah, mate.
Is it possible for a long carbon chain to have alkenes, alkynes, and an OH group?
Yep, can you remind me that, and we'll do a combined one at the end. We'll just come up with this monster molecule and we'll attempt to name it. Alright? We'll put everything in it. Alright? So, we've got propan-2-ol, straightforward, or you can call it 2-hydroxy propane, but this is the preference, okay, that we call alcohols as an ol.
What about 2-propanol?
2-propanol is also acceptable, okay, but I would rather you try and put the 2 next to the alcohol. So 2-propanol is okay as well. David? Matthew? What do you call you David for? I don't know. Alright, aldehydes, let's have a look. We'll still do a 3-carbon chain again, just to make it simple, alright? So 3-carbon chain, and I'll put in all of the hydrogens. Alright, there's no, nothing ambiguous about this one. 1, 2, 3, it's only got one functional group in there. What's the functional group? You would say it's a aldehyde that you'll eventually have to go like that to learn. So it's an aldehyde. Longest carbon chain is 3. This one here is prop and propanal. Okay? Do I need to put a number in there? No. Why not? No number means it's on carbon number 1, but does it make any difference for an aldehyde? It's going to be no difference, is it? They're always going to be on carbon number 1, alright? In most cases. Got to be careful in most cases. Well, for an aldehyde it is going to be terminal.
Do you have to put that dash?
No, you don't have to. No. I've just tried to highlight that there. Alright, so the dash you can drop. Alright, what are we up to? We'll do a carboxylic acid. Let's do the same thing. 1, 2, 3, and I'll do the structural formula for that one. So we start numbering from this point here. 1, 2, 3. Sometimes people forget this carbon. Okay? So for something like this, which will be C2H5COOH, they call that ethanoic acid. They forget this carbon here. Alright? So don't make that mistake. If you are likely to make the mistake, do the structural formula first, and then you can't make the mistake because you've got the carbons in the face. Alright, so this one here will be called propanoic acid. So we add an oic acid, okay, in order to name a carboxylic acid. So it becomes an oic acid. Alright, amines, I think, primary amines are reasonably straightforward. 1, 2, 3, we'll put an NH2 there, and that will be all hydrogens, of course, in that structure. They are. That would be called propan-2-amine, or I prefer this, 2-aminopropane. Alright, but don't quote me. I think we don't even have to name amines in, pretty sure we don't, alright, in the course outline. It's one of the structural, yeah, alright. Primary amines are the only ones we have to name, alright. So, and if you look at the bottom of page 243, alright, they would call this propan-2-amine, alright? Which is the other way of naming it as well. So propan-2-amine for the amines. Esters, alright, esters and ketones we've got to do. When we are doing an ester, and we won't get to this for a few weeks yet, we would always draw the ester structure out. It's a little bit easier to do that. There it is, and I'll put it in. When we're looking at the structure for an ester, when we look at the theory behind an ester and how we make it, an ester is combined or made of two compounds. The compounds in the ester are the alcohol. This is what we're going to react together, and we did it last year, didn't we? Or the practice one? Yeah. And this is my carboxylic acid. There it is. Now, when we name an ester, the alcohol goes first. So I should have drawn it the other way around, it doesn't really matter. So the alcohol goes first, and I prefer to go right back to the beginning, all right, and work out what the alcohol would have been. So the alcohol would have been methanol here. This carboxylic acid would have been, 2 carbons would have been ethanoic. So we'll say that is ethanoic, okay, acid there. And so this would have been methyl. So we put the "il" on the alcohol, okay, methyl and ethanoate. So O8 on the end where it was an oic acid before. So the alcohol goes first, methyl ethanoate is our ester structure. Now again, we'll do a lot more when we get into esters. All right, this is just an overview so you can start the first section on nomenclature shortly. All right, next one is ketones. So ketones, 1, 2, 3. We'll do that one there. CH3, CH3. All right, 3 carbons. It's going to be prop, and 2 one. So we use the one. It's not pronounced one, it's pronounced one. So propane 2 one for a ketone. Anybody happy with that one? So you've got to be able to name alcohols, aldehydes are al, amines are amino, carboxylic acids are oic acids, esters, il and O8. Okay. Ketones are the ones. All right. And Never had a question. You wanted to combine them all together. Okay. So let's have a look at a structure. We'll just randomly draw some sort of structure with a whole lot of things in it, and see if we can apply the rules. If you remember, yeah.
Do they need to follow an order like alkanes, alkynes, or can be?
No, it goes alphabetic. All the substitutions go alphabetic. So we'll come up with a random molecule. So we'll draw the structural formula because it's a bit easier. And we'll put all sorts of things off the side of it. So we'll do that. Let's put that there. Let's put another one down here. What else can we put in there? Is that enough? You want to put an amine there as well? Okay, we'll put down over here. We'll put NH2 there. All right. Now, let's have a look at it. If we go back to the general rules, we now have to work out which side. Well, before we even do that, the first thing I said, and I should have done it myself, was I want to identify all the functional groups. All right. So I'm looking at this one here. So I know here that I've got an amine functional group. Okay, this is the skill that you need to pick up fairly quickly. If it's got an OH not attached next to a C double bond O, this is an alcohol, just to pick out the functional groups. These we're not worried about, it's just substitution to straight carbon chains. And this one would be what? That one is a ketone somewhere in the structure. Okay. So, we've identified the functional groups, all right? We now have to work out where we number the carbon chain from. Where do we start? The right or the left? Who thinks the right? Who thinks the left? Who thinks I don't know? Right, yes, you're honest. Okay, so here's the first carbon in the chain. Okay, here's the first carbon on that side. Which one wins?
Oh, right.
This one wins, doesn't it? Okay, we go to the next one. All right, they're even. The next one, this one wins again. So straight away, hopefully you can see we're going to number it from the left, according to our picture.
Yeah, because I thought it was like the total number should be lower. So like if you number from the right, you have 2.
Yeah, we'll do both because the total number of substitutions has to be the lowest if there's any confusion. So we're going to name it 2 ways, and then we'll just do a final check. All right. So this would be 1, 2, 3, 4, 5, 6, 7. Looks like a hex is going to be in the name. Hept, sorry, hept. Hept is in the name. All right, now, what are the substitutions? Well, let's look at all the substitutions. We've got a methyl here, and we've got a methyl here, and here we've got an ethyl. A, C, D, E, F, G, H, I, J, K, L, M. So the E would have to come before the M in the substitutions, wouldn't it? All right. So let's just start to write that down. 1, 2, 3. So that would be 3 ethyl. 3 ethyl. Where do we go next? 2, 4. 2, 4 dimethyl. Alright, so where do we go now? Now we're going to start to think about these functional groups, don't we? Okay. So we've actually got these functional groups. We've got an ol, and we've got an amine. Okay. Or amine if we name it, okay, with the amine at the end. And we've got, what else we got? We've got an one. So we've got an ol, we've got an amine, and we've got an one. Alcohol, amine, and an one. So what are we going to put in order at the end of the name then? Of course I haven't finished yet, so it's going to have to be heptan, more information, heptan. So what's the order going to be? A, M, that's logical. Let's do that one. Let's do the amine first, okay? Heptan, now we do need to put one amine. What would go next? It's gone. O-L-N-N. The O will go next. Okay, then it will be 4-ol. What's left? 6-one. 4-ol and then 6-one. Very simple name, alright? 3-ethyl, 2,4-dimethyl, heptan, 1-amine, using that type of structural formula name. 4-ol, 6-one. Now, Will said, what about if we reversed it? Right, how do we know that that's the right way to name the structure? Okay, so if I note it the other way around, 1, 2, 3, 4, 5, 6, 7. And sometimes you'll have this in the more complex structures, all right? You get that from Mr. Knack, you can just barge in. All right, so if we're going to go that way, all right, how will the name change? How is it going to be different if we decided to name from the right-hand side? Dave, what's going to happen? Yes, they are, but if we number it from the right-hand side, let's go back and we'll now order it as if we've numbered it from that side, okay? If we did, the ethyls would now be, or the ethyl group, it would be number 5, wouldn't it? It would be 5-ethyl. Okay, so we've got a 5-ethyl. Then it would be, what would it be? It would be 4,6-dimethyl. Correct? The hep stays there. Heptan. Now the 1 would be a 7. Can you see it's not going to work? I don't have to go any further, do I?
Yeah, you do.
I do? Okay. Amine. Okay. The ol would be a 4. Doesn't change. Okay. And the one would become a 2. All right, everybody happy with that?
Yeah.
So, if we were uncertain about which way to number the carbon chain, we add them up. 6, 4, that's 10, 11, 11 and 6 and 3, 20, is it? So for that one there, it adds up to 20. That's the total of all the substitutions. This one adds up to what? 28. So bad luck, that's not the one. It must be the one where the total substitutions is least. Okay? So that covers naming. Everything you could possibly want to know about naming, pretty much. But we didn't do aromatic compounds. We do not have to name aromatic compounds. Never.
So these to be the least then?
Yes, the total substitutions, if you are in doubt, if the molecule looks to be symmetrical, and you're not sure, do I number it from the right or do I number it from the left? Not that it's right or left, okay, but if you know what I mean when we draw it in 2 dimensions. So if you're unsure, do both, add them up, the last number wins.
That's for the complex ones.
That's for the really complex ones, and you will come across some structures where you think, I'm not sure whether I've numbered it in the right, from the right direction,
Okay.
and so you're just going to do a double check, and that's your double check. All right? And then apart from that, it's really then everything's alphabetical. Okay? And if I gave you this structure, you know, if I was talking to you on the phone, and if I didn't have a video operating, if I said, I've just come up with this fantastic compound, 3-ethyl, 2,4-dimethyl, heptane, 1-amine, 4-ol-6-one, and it gives all students an A at Year 12 chemistry, you would be fighting to get that molecule. You'd say, oh, what did my chemistry teacher say? All right? I need to make that drug. All right? Anyway, you could draw it. Now, the next level is, when we get further down the track, I could actually now ask you, how do I make it? Okay? How do I make that structure? Because as we go through each one of these functional groups, you will slowly learn, if I want to make an alcohol from an alkane, how do I do it? If I want to turn an alcohol into a ketone, that means it must have been initially on this carbon, it must have been alcohol there. Okay? If I needed to get an NH2 there, how do I do that? Now, it's a bit outside the scope of the course, we don't do some of those structures, but that's actually how people synthesise molecules in a lab. As soon as you can isolate the structure by using NMR, which we haven't talked about, but as soon as you can identify the structure of the molecule, as soon as you can draw it, you can make it. Okay? That's all you need to do. Isolate the structure and you can make it. Alright, there's a lot of money invested in all sorts of structures where people obviously need, alright, certain drugs that do certain things. They can identify the structure in nature, and of course once they can identify it in nature, they can synthesise it in the lab. Alright, any questions about nomenclature? Because we'll stop there before you all go to sleep. Anyway.
Do we need to be able to draw from the names?
Yes. Got to go both ways? Yep, you'll see the questions we're going to throw at you in a minute. So we're going to do everything on nomenclature. We're going to do the textbook questions, and then I'll give you a whole series of questions that you're going to practice on. Alright? Alright, any questions on nomenclature? Alright, that's all we're getting on nomenclature. Alright, we should have really covered most of that last year, but I've just tweaked it a little bit, okay, with the more of the functional groups.